Hello everyone. Let us start our class now. Almost 8 মিনিটের মতো ওয়েট করছি আর আমার মনে হয় না কেউ জয়েন করবে, সো আমরা ক্লাসটা শুরু করি। আচ্ছা, তো আজকে আমরা চ্যাপ্টার 6 শেষ করব। টপিক খুব একটা বাকি নাই, খুবই সিম্পল কিছু টপিক বাকি আছে। পড়ালে দেখবেন যে আসলে এগুলা অলরেডি আপনারা জানেন, এই টাইপের জিনিসই আজকে আমি পড়াবো। ফার্স্টেই আমরা শুরু করি, যেটা মানে এই কথাটা আমরা সবাই খুব জানি, অর্থোগোনালিটি। উই নো দিস টার্ম। ওকে, this means perpendicular. So if you have two vectors, and if they are at 90 degree to each other, you can say that these are orthogonal to each other or perpendicular to each other. So orthogonal মানে হচ্ছে দুটো ভেক্টরের মধ্যেকার অ্যাঙ্গেল যদি 90 ডিগ্রি থাকে। আচ্ছা, there are two more terms that we know. One is scalar product and another one is vector product or cross product. We know this, right? Scalar product or dot product means if you multiply two vectors, you will get a what? You'll get a
scalar
constant, a scalar term. You will get a scalar term, right? So এখানে দেখেন, এই যে আমরা এখানে ডট ম্যাট্রিক্স নিয়ে কাজ করতেছি ফার্স্টে। So if there are two matrices and if you need to multiply them together, that means you need to find out their dot product. You will first transpose the x and then multiply it with y, and then you can get this 1 into 4, 2 into 5, and 3 into 6. Also, it looks something like this. Vector notation, it looks something like this, right? This is one vector, this is another, and you can multiply all the components and add them up together to get the scalar number or the scalar product. Does it make sense? If you multiply or if you dot product a vector with itself, what happens? Suppose you have a vector A. Okay, you have a vector A and its components are x, y, and z. If you dot product A with A, you get x squared plus y squared plus z squared. And what is the magnitude of A? Root over x squared plus y squared plus z squared. So if you inner product with itself, that means if you multiply A with A, you get the square term of the magnitude. This is your magnitude. And you get the square term of the magnitude if you multiply A with itself. This is known as inner product and it is also called L2 norm. ঠিক আছে, এটা মানে হচ্ছে নিজের সাথে নিজের গুণ করে আসলে আমরা ম্যাগনিটিউডের স্কয়ার পাই। সেখানে ডট প্রোডাক্ট নিয়ে আবার কথাবার্তা বলছে। ডট প্রোডাক্ট আরেকভাবে বের করা যায়, which is this. We know this, right?
Yes, ma'am.
We know this. So if the angle between A and B is 90 degrees, if theta is 90 degree, then cos theta is equal to what? 0, right? So A dot B is equal to 0. So if you multiply two vectors together, that means if you find the dot product and if you get 0, then you can say they are orthogonal to each other or they are perpendicular to each other. Am I making sense? খুবই সোজা, এটা একেবারে ইন্টারমিডিয়েটের কনসেপ্ট। ঠিক আছে, আগাবো। এই যে দেখেন, এটাই বলছে দুটো ভেক্টরের মধ্যে অ্যাঙ্গেল যদি 90 ডিগ্রি হয়, you get a 0. Now there is another terminology which is orthogonal set. Orthogonal set. So what is a set? Set means collection of vectors. There are many vectors in a particular set. An orthogonal set means each pair of the vector in the set will be orthogonal to each other. তার মানে A should be perpendicular to B, B should be perpendicular to C, A should be perpendicular to C. That means A dot B is 0, B dot C is 0, and C dot A is 0. কেউ কি আমাকে বলতে পারবেন যে if these two terms are equal or not? Are these two terms equal?
Yes, ma'am. They are equal.
Yes, right? Because it does not really matter in which Direction, you are multiplying them. It is not a vector product. In vector product, the direction would matter, right? The direction of the resultant would matter, but here it does not really matter. So if there are three vectors in there, so you need to check 3C2 pairs, check that whether all of these pairs are perpendicular to each other. If any of the pair, if the two vectors in any pair are not perpendicular to each other, then you cannot say that this is an orthogonal set. The first condition of being an orthogonal set should be that if you take all the pairs from that set, all those pairs have to be orthogonal. Take a set. Each vector is perpendicular to the other. So that was orthogonal. It was orthogonal vectors. Then there is another terminology which means orthonormality. So orthonormality. So the first condition for orthonormality is the vectors are orthogonal. That means their dot product is 0 or the angle between them is 90 degrees. The second point is the length of the vectors is 1. The length of the vectors is 1. So normal আমরা বলি না normalize করা বা এরকম কিছু করা, সেটা মানে হচ্ছে ভেক্টরের লেন্থ আসলে 1 বানাও। তো অর্থনর্মাল সেট মানে হচ্ছে তাদের প্রত্যেকের ভেক্টরের লেন্থ গুলা 1 হবে, and they will be known as unit vectors. So condition 1 is same as orthogonal vectors, that the vectors have to be orthogonal, and condition 2 is a special addition which says the length of the vector has to be 1. That means all of the vectors have to be unit vectors. So if two vectors are given, you will first check that whether or not they are orthogonal. So you check whether or not they are orthogonal. 4 into 1 minus 6 plus 2, which is 0. So these are orthogonal. However, you need to check that whether or not these are orthonormal as well. For checking that they're orthonormal, there is another condition, which is the length of the vector has to be 1. So if you check the length of the vector, you will see that they are not 1. দেখেন 4 square plus 2 square plus 1, which is 21. So এদের length আসলে 1 না। So length যদি 1 না হয়, 1 কেমনে বানাবো? How can we make the length of the vectors 1? We can divide the vectors by their magnitude, the desired length, which is 1. এই যে দেখেন এখানে ভেক্টরকে, যে ভেক্টরটা গিভেন ছিল তাকে হচ্ছে আমরা এখানে ম্যাগনিটিউড দিয়ে ভাগ করে এটা পাইছি, এন্ড দেন আবার লেন্থ চেক করছি এই ইউনিট ভেক্টর, এগুলো ইউনিট ভেক্টরস, এগুলোর লেন্থ আবার চেক করছি, দেখছি যে হ্যাঁ দিস আর 1. So even if your vectors are not orthonormal, if they're orthogonal, you can make them orthonormal by normalizing the vector. What do we mean by normalizing the vector? That means making the length of the vectors is equal to 1. That means dividing the vectors by their magnitude. We do the same for B, and we call this normalization and everything. So suppose there are two set of vectors. Sorry, there is a set of vector with two vectors. So let us check that whether or not they are orthonormal. So the first thing that we need to check, so let's say this is your first vector, 1 by root 5, 2, 1, this is the first vector, and this is the second vector, 1 minus 2. And if you dot product them, you'll get 2 by root 5 minus 2 by root 5, which is 0. So this is 0. And then you need to check their magnitudes. By checking their magnitudes, you see that both of their magnitudes are 1. So the set of the vector is orthonormal. So the question may come that prove that the set of the vector is orthonormal. Then you just prove it, yes or no. If the question asks you, if the set is not orthonormal, then make it orthonormal. So how do you make it orthonormal? By dividing each of the vectors by their magnitude. ঠিক আছে? The process is known as normalization. এগুলো এখানে normalizationের কথাবার্তা এখানে লিখছে. So there is a theorem, you know, that we do not really need the theorem, just হচ্ছে বোঝার জন্য we use this type of theorems. So, orthogonal or orthonormal matrices are matrices in which the column vectors form an orthonormal set. Each column vector has length 1 and is orthogonal to all other column vectors. That means, suppose there is a matrix. There is a matrix and there will be column vectors, right? You will treat those column vectors as separate vectors. And each of those column vectors will be perpendicular to the other, and the length of the column vectors will be 1. That means if you consider the column vectors as separate vectors, you will find that those vectors, that means those column vectors, form an orthonormal set. And what is an orthonormal set? Each pair will be perpendicular to each other, and the length of the column vector should be 1. All of their lengths should be 1. Okay. So what is the benefit of using an orthonormal matrix? Normally আমাদের ইনভার্স করাটা অনেক ডিফিকাল্ট না? Inversing is a very computation expensive operation. But if your matrix is a square orthonormal one, then you can just transpose the matrix to get the inverse one. So we also know this, that suppose there is a matrix A, and if you multiply it with its inverse, you get an identity matrix. And for Q, this inverse is simply transpose. So you get the I matrix back. That means the identity matrix. What is an identity matrix? Identity matrix means that there will be all
value will be 1.
right. All the values in the principal diagonal will be 1. So there is a matrix. This is a square matrix. There are 2 column vectors. The first column vector we name it A, and the second column vector we name it B. And we see that if we multiply them together, that means we find the dot product, we get 0 back. That means they're orthogonal to each other. And if you find their magnitude, you see both of their magnitudes are 1. So this is an orthonormal set. Since the column vectors are orthonormal to each other, so Q is an orthonormal matrix. Q is an orthonormal matrix. Okay. This was literally the prerequisite from what is coming now. এটা আসলে একটু difficult আমি বলবো না, দেখে মনে হচ্ছে 12 পেজ বিশাল, but this is not that difficult. এটা খুবই সহজ if you can remember the formula well. ফর্মুলা মুখস্থ করার টেকনিক আছে। আচ্ছা, সো ব্যাপারটা যেটা হচ্ছে যে নরমালি কি হয়, একটা আমাদের ম্যাট্রিক্স থাকে। সো ফার্স্টে যেটা করতে হয় যে একটা ম্যাট্রিক্স থাকবে, suppose this is a matrix A, কি এটা নড়তেছে কেন? Suppose there is a matrix A and the column vectors are known as U1, U2, U3. You will apply Gram-Schmidt process. This is a process that you will apply to the original basis and you will get the orthogonal basis. That means now all the column vectors are perpendicular to each other. And next you will apply normalization to them. That means you will normalize the P1, P2, P3, P4, whatever the vectors there are. After normalizing, you get the orthonormal basis. Normalize করার পর you get the orthonormal basis. So this is the formula for calculating P1, P2, and P3 from U1, U2, U3. So P1 is equal to U1. So the first one is fixed. The second one is P2 is equal to U2 minus this. And third one is P3 minus U3 and this. So what will be P4? P4 will be U4 minus
U4 into
4 dot
P1
P1 divided by
divided by
P1
P1
dot
dot
P1
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 into P1.
তারপরে সিমিলারলি এটা P2 P3 পর্যন্ত কি হবে ক্যারি ফরওয়ার্ড হবে তাই না
জি জি
হ্যাঁ so this is how you generate the formulas as you go এখানে দেখেন there are three vectors u1 and u2 and u3 and you will convert them to orthonormal vectors using Gram-Schmidt process. So P1 is equal to U1, P2 equals to this formula right there. Formula আমি explain করতেছি না, just basic dot product দিয়ে বের করার পরে you get this back. And in P3 you get this. So P1, P2 and P3 are orthogonal vectors, and if you find their if you divide them by their magnitude, you'll get normalized vectors, which are Q1, Q2, and Q3. So this is the formula of producing Q orthonormal matrix from a very basic matrix, say A. Achha. Now remember, when we started this chapter, we say that this chapter is all about solving overdetermined system. That means there are more number of equations than what you actually need. Do you remember?
Yes, ma'am.
Achha. So we will try to solve those overdetermined system using this QR using this orthonormal matrices. Okay, so this method is known as QR decomposition. It's almost like LU decomposition. You know LU decomposition, right? So if you decompose A into QR, Q is an M into N matrix with orthonormal columns. If A is an M into N matrix, because A is an overdetermined system, M is greater than N. That means the number of rows will be greater than number of columns, and R will be an upper triangular matrix of shape N into N. So you will find A Q from A using Gram-Schmidt process. একটু আগে যেটা প্রসেস দেখালাম না যে P1 equal to P1, ওটা দিয়ে আপনি A থেকে Q বের করবেন. And then you find R using this formula. This is the second formula. I'm not saying how to find this formula. It is not necessary. So the step one will be finding Q from A. The step two will be finding R using Q transpose A. So you have your Q and R. Now it's time to find your X. So the equation system will look like that, right? This is the equation system. And you need to find X from this. That is the whole point of using whatever the systems we are using. So now, to পড়ে লেখা আছে, এটা কেন এত পড়ে লেখা আছে আমি জানি না, but পড়ে লেখা আছে. Then you will use this Rx equals to QTB, this formula, to find out your X. So the first one was, আমি আবার লিখতেছি, A থেকে Q বের করা. Second one was R equals to QTA. And third formula is Rx is equal to Q3B. And you can find your X from these three formulas. So let's see an example. Example দেখাই কারণ formula দেখানোর থেকে example দেখানোটা better. So this is an overdetermined system. There are three nodes given. We always know that for three nodes, you will what? Get a polynomial of degree 2. But however, you can be asked to derive a polynomial of degree 1 from these three nodes. So this is a polynomial of degree 1. And you will place all these values in this equation to find out this matrix form, right? We saw this in least square approximation, the very first topic of this chapter. So your A has two column vectors U1 and U2. U1 is equal to P1 and this, and P2 is equal to U2 minus U2 dot P1, P1 dot P1 and this. So you do the calculation and you find the two P1 and P2. These two are orthogonal vectors, and you need to normalize them by dividing the P1 and P2 using their dividing them by their respective magnitudes. You get Q1 and Q2. You stack them vertically and you get Q. This is your orthonormal matrix. ঠিক আছে? This is the same dimension as A. This is the same dimension as A. Then you have R equals to QT A. Remember, this was your second step for finding R. So Q transpose A, U transpose Q. That means you make the columns the rows and rows the columns, whatever, however you feel it, right? And this is A. You multiply them together and you get this. And then the third formula is this: Rx is equal to QTB. So you have your formula R. You have now your, you know your X. Your X is A naught and A2. That means these are the variables that you need to find. Q transpose and B to given, right? B is given. So you multiply QTB, you get a square, you get a single column matrix, and this is very simple. এটা জাস্ট হচ্ছে আপনি বটম আপ অ্যাপ্রোচে সলভ করতে পারবেন। ঠিক আছে? So this is your A1, and then you will use this A1 to find the values from this equation. So you have two values, this and this. So this is the same as what we did in our least square approximation, where we just multiplied multiplied A with A transpose in both the sides to get a square matrix, and we then process the A matrix however we like. However, this you need to follow this formula. I mean, follow this method, QR decomposition, only if you're told so. ঠিক আছে? তো না বললে আপনি ডিরেক্টলি ওই যে এ দিয়ে দুই পাশে গুণ দিয়ে করতে পারবেন, বাট যদি বলে যে কিওয়ার্ড দিয়ে করো, ইউ নিড টু ডু ইট ইউজিং কিওয়ার্ড। সো এই ছিল আমাদের চ্যাপ্টার 6। কারোর কোনো কোয়েশ্চেন না থাকলে আজকে আমি কিছু ডিক্লারেশন দিব, তারপর ক্লাসটা এন্ড করে দেব। অলরাইট, আচ্ছা, সো রেকর্ডিংটা পজ করছি। আমাদের সানডেতে একটা কুইজ হবে on চ্যাপ্টার 5 and 6,